Okay, we're going to talk about operations with rational numbers. Another way to say this is add, subtract, multiply, and divide fractions. So this is something that you need to be pretty confident on because you'll see fractions throughout Algebra 1. I'm going to say this really super cheesy rhyme to you guys that hopefully will be dumb enough that it'll stick in your heads to help you remember what to do, like what are the rules with working with fractions. So here we go. When you're adding up or taking away fractions, don't be a hater. Bottom numbers gotta be the same common denominator. Multiply fractions, no big problem. Top times top over bottom times bottom. And then the last one, dividing fractions, easy as pie. Flip the second fraction and multiply. Okay, I know that was super terrible, but sometimes the more terrible it is, the faster you remember it. So let's just go through what those mean. Just highlight or star this part if you're adding up or taking away. So this is talking about adding and subtracting, and the key is a common denominator. Now, a couple other points I want you to add underneath that box, because it seems to be a common error that students make, is to get a least common denominator, you're going to multiply both the top and the bottom of the fraction by that whatever number will get a common denominator. So you're not just going to multiply the denominator. But then when you add or subtract the two fractions, you're going to keep the denominator the same and only add or subtract the top, the numerator. And we'll talk about that more in an example if that didn't make complete sense yet. So then multiply fractions here. And the key is you're just going to multiply top times top and bottom times bottom. So numerator of one fraction times the numerator of the other fraction, and then over denominator of one fraction times denominator of the second fraction. And then dividing fractions, all you have to remember is that you're going to flip, or another name for flip is reciprocate that second fraction, and then you're going to use the rule for multiplication. So let's do some examples. So we're going to do all four operations with the same fractions so that you can see the difference in the procedures for these. So here we're going to add up the two fractions. So don't be a hater. We got to get a common denominator. So here my least common denominator is going to be 15. So I'm going to multiply 2/3 times 5 over 5. So this is where I'm saying when you get a common denominator, you have to multiply the top and the bottom by the number that gets you the common denominator. So for the second fraction, we're going to multiply times 3 over 3. And then now we're multiplying fractions, so no big problem, top times top over bottom times bottom. So we're just multiplying in the process of getting a common denominator. So this is going to end up being 10 over 15 plus, and then 4 times 3 is 12, and 5 times 3 is 15. And now this is that second part of this. When you're adding and subtracting, you only add or subtract the top number. So we're not going to do 15 plus 15 and put 30 right there. That's not correct. You're going to keep 15 on the bottom and only add the top. So that would end up giving us a 22. So now let's go on to subtract. We've already found the equivalent fractions with common denominators, so I'm not going to multiply those again. I'm just going to go ahead and say that another way to write 2/3 is 10 over 15, and another way to write 4/5 is 12 over 15. Again, we're only subtracting the numerators, and we'll keep the denominator at 15. So this is where our concept of adding and subtracting integers rolls into fractions, because on the top we're doing 10 minus 12. We're subtracting signed numbers, so we keep the first, change subtraction to addition, and then change that positive 12 to a negative. The two numbers are going to fight. Who wins is negative, so you're going to have a -2 for your numerator. If we're multiplying the two fractions, the first thing I always tell students to check is if you can simplify anywhere. So not only can you simplify from the numerator and the denominator of one fraction, but when you're multiplying, you can also simplify diagonally. So if you look at these two numbers right here, and they don't have a common denominator, nor does 2 and 5. So at that point, we can go ahead and just multiply top times top and bottom times bottom. So there we end up with an 8 over 15. And finally, to divide, our rule is it's easy as pie. We flip the second fraction and multiply. So instead of 2/3 divided by 4/5, you would get the same answer if you did 2/3 times 5 over 4. Now, this is a case in which we can diagonally simplify, because look at 2 and 4. They both have a 2 in common, so we can divide 2 by 2 and change that to a 1, and 4 by 2 and change it to a 2. Now we're multiplying fractions, so no big problem. Top times top, so 1 times 5 is 5, over bottom times bottom, so 2 times 3 is 6. Okay, next example. So first thing, we're adding up, so we have to get a common denominator. Our least common denominator for 3 and 7 is going to be 21. So to change that first fraction, so it has a denominator of 21, we need to multiply by 7 over 7. Make sure you multiply the top and the bottom both by 7. So we'll have 7 over 21. For the second fraction, we need to multiply times 3 over 3. So we're going to end up with a 6 over 21. Now we keep the denominator 21. 7 plus 6 is 13. Next, we subtract. We've already found our equivalent fractions with the same denominator, so I'm going to just go ahead and keep that. So 7 over 21 minus 6 over 21. Again, keep your denominator 21. 7 minus 6 is 1, and you're finished. So now I wanted to also show you some different ways you're going to see multiplication. Sometimes multiplication is symbolized with the dot, and sometimes you'll see parentheses. So it still means multiplication. So here, when we multiply fractions, no big problem, top times top. So 1 times 2 is 2, over bottom times bottom. 3 times 7 is 21. And finally, dividing fractions, easy as pie. We're going to flip the second fraction and multiply. Always check to see if diagonal numbers that are situated diagonally with each other, see if they're simplifiable. Here they're not, so we can go ahead and do the top times top. So 1 times 7 is 7, and bottom times bottom. 3 times 2 is 6. Next example. Now we've got some negative fractions that come into play. You're going to still apply the same concepts of adding and subtracting integers. So we're just going to be rolling that concept into another one. So again, our least common denominator. Look at your denominators are 3 and 11, so the least common denominator here is 33. So we're going to multiply our first fraction by 11 over 11. That's going to give us a negative 44 because a negative times a positive is a negative. Over 3 times 11 is 33. The second fraction we need to multiply by 3 over 3. So 6 times 3 is 18, and 11 times 3 is 33. Okay, so now we've got a negative plus, and this is a positive. If the plus here is the operation, then the sign of the second fraction is positive. So the two numbers are going to fight. So what you need to think is, what is 44 minus 18? We need to subtract their absolute values because they fight, and we get 26 right here. And then you ask yourself, which number is bigger, or has a bigger absolute value, and that would be the 44 over 33. So that means the negatives win. So your final answer is a negative 26 over 33, and you're done. So let's move on to subtraction. I want you to notice we're subtracting sign numbers, so we keep the first, change the operation of subtraction to addition, and then because there's no sign on the 6 over 11, we can create a positive there. Now, I'm not going to redo the finding the common denominator, so I'm just going to pull these numbers over. So we'll have negative 44 over 33, and then subtracting sign numbers, we will keep, change, and then change, and this one is a negative 18 over 33 now. Now, the two numbers are both negatives. That means they're going to work together. In other words, we are adding their absolute value. So 44 plus 18 is 62 over 33. And then all there are negatives, so that means the negatives win. Oh, I want to mention one thing. Some of you probably have been feeling like I'm not finishing these questions because I'm leaving them as improper fractions. 99% of the time in algebra and beyond, your teachers will prefer improper fractions to mixed numbers. My rule is, give me an improper fraction every single time. The only exception is if the original question was using decimals or mixed numbers, then I will allow you to keep that consistent. And then if you're dealing with something like money, then obviously you can turn things into decimals. But other than that, I almost always will prefer an improper fraction over a mixed number or a decimal. So this example here, we're going to multiply fractions. First thing, I want you guys to remember that when you multiply a negative times a positive, you get a negative. The next thing is we do have some things that we can diagonally simplify here and here. 6 and 3 are both divisible by 3, so 3 divided by 3 gives us a 1. 6 divided by 3 gives us a 2. Now we can multiply, so negative 4 times positive 2 is going to be a negative 8, and then 1 times 11 is 11. And finally, we're dividing, so we need to flip or reciprocate the second fraction and multiply. We do also have numbers that we can diagonally simplify here. 4 and 6 are both divisible by 2. So 4 divided by 2 is 2, 6 divided by 2 is 3, and now we can multiply top times top and bottom times bottom. One side note here, you don't have to diagonally simplify. However, it usually makes your math a lot easier, and anything you can do to try to avoid careless errors is usually worth it. Okay, our final example on this page, we want to first get our common denominator. Our least common denominator this time is 9. So it's kind of nice. We don't have to multiply the first fraction at all. And the second fraction we can multiply by 3 over 3. So it's a negative 2/3 times 3 over 3. So this is going to end up being a negative 6 over 9. So now the two numbers are both negative. That means that we're going to add their absolute value. So we're going to think 7 plus 6 is 13. We keep the denominator the same. Now who wins is the negative. Next, we'll go ahead and, since we've already found common denominators here, we're going to go ahead and keep those. So 7 over 9. And now it's going to be a minus a negative 6 over 9. Now we're subtracting sign numbers, so we keep the first fraction. We change subtraction to addition, and we change the sign of the second number. So now we have a negative 7 over 9 plus 6 over 9. We have a negative and a positive, so they're going to fight. So we're going to subtract 7 and 6 to get 1 over 9. And then because negative 7 over 9 has a greater or larger absolute value than 6 over 9, our answer is going to be a negative. Okay, next one, we're dealing with a negative times a negative, so we can automatically say that our answer will be positive. So we're multiplying fractions, no big problem, top times top. So negative 7 times negative 2 is positive 14, and then 9 times 3 is 27. And we've already said the sign stays or becomes positive. And finally here, we're dividing fractions, easy as pie. We're going to flip the second fraction and multiply. So negative times negative again is a positive. Here, because we flipped it, we've created numbers that we can simplify diagonally. 9 and 3 are both divisible by 3. So 3 divided by 3 is 1. 9 divided by 3 is 3. Now, negative 7 times negative 1, that gives me a positive 7 over 3 times 2, which is a 6. All right, so I'm going to do the ones that I don't know if you guys will say they're tough, but maybe tougher than the ones on the front, because sometimes they will require some regrouping and they're sometimes a little bit messy. So first, let's talk about questions where we're dealing with mixed numbers. So here, I would accept an answer of a mixed number at the end. I would also accept an answer as an improper fraction. So what I'm going to do with this first question is I'm going to kind of separate out the fractions and the whole numbers, and then if I need to regroup at the end, I will. So here I'm going to say, okay, well, I'm going to do the 2 plus 3 part, and then I'm going to do the 1/5 plus 2/3 part, and then I'm going to put the two together. So 2 plus 3 is 5, and then we need to get a least common denominator for the fractions. Our least common denominator will be 15. So we're going to multiply the first fraction by 3 over 3, and the second fraction by 5 over 5. So the first fraction is going to become 3 over 15, and the second fraction is going to become 10 over 15. So 3 over 15 plus 10 over 15 is 13 over 15. What's nice is that this number isn't bigger than 1, so all we have to do now is put 5 and 13 over 15 together, and we've got our answer. If you would like to change it to an improper fraction, I probably would appreciate it, but you don't have to. All right, let's go on to example 2 here. I'm going to do the same thing. I'm going to separate these out. So keep in mind this entire second fraction is negative. So we're going to do a 7 plus negative 5, and then the 2/3. It's not going to be 2/3 plus 2/7. It's going to be plus negative 2/7. So keep in mind if that second number is negative, both the whole number and the fraction are going to be negative. So let's do 7 plus negative 5. That gives us a 2. And now let's do a least common denominator with the fractions. It's going to be a 21. So we're going to have to multiply the first fraction. Let me move this around a little. We're going to multiply that first fraction by 7 over 7 and the second fraction by 3 over 3. That first fraction is going to become 14 over 21. And then the second fraction is going to end up being negative 6 over 21. So together that gives us an 8 over 21. And now we've got a positive 2 and an 8 over 21. So we can just put those together and say 2 and 8 21sts. Okay, so now what happens if we do have to regroup? Let's do some examples like that. So I'm going to go ahead and again do whole numbers together and fractions together. So we're going to do 5 plus 2, that gives us 7. And then we're going to do 5/6 plus 2/3. Our least common denominator is going to be 6, which is nice. We only have to multiply one of our fractions. So this is going to become 5 over 6 plus 4 over 6. And that gives us a 9 over 6. Well, what is 9 over 6? Because we're kind of separating out the fraction parts and the whole number parts, 9 over 6 can be made into a mixed number and become 1 3/6. So that means that we kind of have to regroup that. We've got to put the 1 over in the whole numbers part. So now we have 7 plus 1 is 8, and then we can say 3 over 6. And 3 over 6 is simplifiable, so we need to go ahead and say 1/2. And finally, this one is kind of a messy one. You could initially change these fractions into the mixed numbers into improper fractions. So you could say 2 times 9 is 18, 18 plus 7 is 25. So then you have 25 over 9, and then 6, or negative 25 over 9. And then 6 times 7 is 42, 42 plus 4 is, did I say 42? Yeah, 42 plus 4 is 46 over 7. And then the downside of this is now you're going to have to multiply to get common denominators, and you're going to have to do 25 times 7 and 9 times 7, and then here you're going to have to do 46 times 9 and 7 times 9. So your numbers are going to get big and messy. It's totally legitimate though. So if you prefer always changing mixed numbers into improper fractions before adding them together or subtracting them, then that's completely fine. But I'm going to still show you how to deal with this, kind of separating out the whole numbers and the fraction. So here, remember, this whole thing is negative. So we're going to have a negative 2 plus 6, and then a negative 7, a negative 7 over 9 plus 4 over 7. So, okay, so negative 2 plus 6, that's going to give us a positive 4. And then negative 7 9s plus 4 7s. We need a least common denominator, and that one is going to be 63. So I'm going to multiply the first fraction by 7 and the second fraction by 9 over 9. So this will end up being a negative 49 over 63 plus a 36 over 63. So the two numbers are going to fight because one's a negative, one's a positive. So we're going to subtract 49 minus 36. That gives us a 13 over 63. Because the absolute value of that first fraction is bigger than the second fraction, that means the sign is going to be negative. So this is a negative 13 over 63. So I want you to recognize that this whole number, we don't have any fraction to subtract this from. So you can't say that this is like negative 4 and 13 over 63. Like, you can't just put them together. What we're going to have to do is essentially borrow. So here's what you need to recognize. 4 could be written in as 3 and 63 63rds. This part has a value of 1. But I want you to notice now we've got a fraction that we can subtract from. So now what we can do is we can do 63 over 63 minus 13 over 63. So we've still got the whole number of 3, and then 63 minus 13 is 50, and 63 is our denominator. And now we're done. So hopefully that made sense. Let me know if you have any questions on that when I see you next.